Okay, so this is a basic overview of what Fabric Engine is, and what I'm going to be showing in this video is actually what you can do with it for motion capture data. And basically what I'm going to show is this script right here, and that I'm using to post-process this data from the Carnegie Mellon library, motion capture library, and how I can detect ground collisions, how I can store the velocity of the center of gravity, and then how I store all of this data in a JSON file that is easily read in MATLAB. So if I scrub right here, I can see the data, see it's all working correctly. And if I play it until the end, you can see it's going to generate a file right here, which has neatly stored a very organized file with all the animation from all the keyframes, all the 300 keyframes for all the different animation channels I have configured it. So do this, you see that I have the keyframes for the orientation X, Y, and Z, and so on. So here I have the orientation of the hips, but I also have the orientation of all the other joints, like for example right here I have the L hip joint, for example, and then at the end of the file I have some custom data like the right foot contact, left foot contact, and also the velocity right here for the center of gravity. Okay, so this is all done by this graph, and then we can call this graph from a Python script like this and run it all over our library, our motion capture library. So I'm going to show this kind of like step by step. How do you come from prototyping until this phase right here? Okay, so I'm gonna load the first example, which is just prototyping, so you kind of again get the idea of how this works. So basically right here we have these nodes, and these nodes can be very low-level nodes. For example, if I press tab right here and insert a add node, you see this is just a wrapper. If I press shift and double click it, you see this is just a wrapper for the addition operation. So it's inside it is just this code, all right. And it could also be more like a preset. So for example, loading a FBX character, it's actually a preset of other nodes. Some of them are presets of even other nodes or are code. So like this is a code. Let me see. I guess pretty much code right here, but it could be nested many times. Yeah, I don't have an example right here, but so like right here the draw operation is a preset, and in here we have another preset, and so on and so forth. Okay, you can explore all the existing presets right here, and if you have extra packs, so this fabric and DFG and variables, they come from factory, and then you can have your user presets or code. And right here I have the extension, my extension is called Fabric Utils, and here I have some presets, some code, and you can just drag and drop right here. Or I can't do this in here, I gotta do this in here. Or I could just press tab and look for them like this. Okay. And then also very importantly, you have the ports, and each port you see has a color, and this color is coding the type of the data that's in there. So here, for example, time is a float or scalar data, and the animation right here is actually an animated character. So if I just hover the mouse over here, you'll see it's a character type of data. Okay. And for example, the character is actually composed of different types. So for example, I know each character is composed of a skeleton, so I could do a get skeleton, for example. Then I'll have the skeleton of the character, and if I want to see what that data looks like, I could report. It's just basic like print, and then execute this print, and I'm gonna see all the value right here. So this very basic stuff. There are some Fabric Engine tutorials you can find to how this works. So basically you have some code and some presets, and you can use what's given, and you can code your own also. So what's relevant in this for motion capture data? So we could do just reading the data, which is interesting, and looking at it and seeing if there are some problems with it, and we can localize this data. We could retarget this data, and we could extract implicit data from this data. Okay, so for example, I have created here a preset called localize pose, which if you double click it is just a bunch of logic and data manipulation. And for example, I could plug this in here and then plug this out there, and I'll get a error message because my properties are not well set. So I have to use a root bonus reference. I gotta give it a name, and basically what I have right here. Okay, gotta scale this. So I'm gonna pass this over here, scale factor, and what I have right now, it's a data that is localized. And now, for example, if I was doing classification data to detect the walk cycle, this would be much more useful than this, because independently of where the character is looking at, I always get the correct pose. Okay. And all these presets, they have this automatic generated UI, so it's very easy to expose your properties, your settings. Okay, and also since it has this input of a character type, and this load BVH, which I was using right here, also has a character type, but could use it to fit other data in here. So this, and you can see I have the localization of this also, just like I had the other. Okay, so like right here I'm localizing to reference pose, and the reference pose of this BVH was here in the center of the world, and this FBX was different, but also of course I can manipulate that also. And okay, so this is character localization. Other things we can do, but we could, for example, detect ground collisions. So I could use another preset which I have built previously right here, which is a footstep constraint solver, and I could just import it in here, and I'll input some ankle pose right here. So I could get my ankle from my animation. So get the pose. So get the pose from the character, and then I'll get the bone exfo from this pose, and then I can input this right here. Oh, yeah, this one is actually a mat44. It's basically just a matrix, and here it's another type of coding the matrix, which is an exfo. So just do a mat2 exfo or exfo to mat44, and then plug this data in here, and then I could get an output position and a detection here, a toggle, if the foot is on the ground or not. So I need to know if I'm getting the correct bone. Right here I have to input an index, and I don't know the index of my foot, so it had to get the find it by its name. So just find the bone right here, and then I'll get the skeleton again. So get the skeleton, find the bone. In this case, my bone is named right, left foot. Then I'll put this index right here, and I'm gonna report this value. So I'm gonna report if this is true or not. So right now it's false. It says it's not on the ground, but I know it is. So I gotta change the properties right here. So just put right here the rig scale, and then change the height. I actually just need to change the right height. I'll just draw the debug right here. Okay. So when I draw the debug, I can see the distance from the height of the feet to the height of the. Okay. Okay. So I need some speed, because we want to detect if it's perfectly still, and the motion capture data is never so still. So I have to up this a bit. So now it detects true, false, true and false, true and false right here. You can also see using the draw debug right here, the draw debug property, we can see the positions in red, which is detecting the footstep. So it's kind of high right now, so I can put this even lower. So you can see it's kind of getting the right position right here. Okay, and then I could do the same thing for the other foot, of course, and also I could save this data, this true and false, as something I could read in my machine learning application. So another example I want to give, we could get the velocity. So you could get the dynamics of some of your bones. You could, for example, get a node there that is in here, which is called delta vec3, which is just, if you get into it, it's just a very easy preset. There is a variable, and you store the variable, and at the next frame you get the previous value, and then subtract one from another. And if you get, for example, again, get skeleton, then find bone, let's just find bone, the skeleton interface, and connect this to this, this to this, and then get bone exfil, get those, and we get the exfil of one bone, and decompose this exfil into its position, and then do this delta operation. Just put this in here. I'm gonna do the hips now instead of the foot. Hips. I'm gonna draw a vector. I'm going to draw this vector right here, and there's a very big multiplier in here, and you can see, actually it's good. So here we can see the the vector of the motion. It's just like less multiplier. So here you can see if the character moves to the front, I have here it's moving to the front, and if it moves to the other side, it changes direction. So this would be useful to, for example, get the speed and direction of movement of the character. And we could also do other stuff with it. We could, for example, normalize it through in regards to the character height, for example. So we could get the heights of the hip at the bind pose. So we could do like I could get this same hip right here, get bone exfol, same thing I did, but with the bind pose. And then I would have the character height right here. Let's decompose it again. If I report, I'll see I have the character height. Which is this one. And then I could, actually this is before the scale factor, so to do like this. Okay. Then I could divide this data by this height and normalize this speed. Okay, so I have done this before and stored it as a preset, which is here in dynamics. So I get the normalized COG velocity, and you can see it's pretty much the same thing. Just get the delta, set the delta vector as unit, and then get the speed, divide the speed by the height of the character, and then, which is here the y x value, and then multiply the size of the vector by this normalized speed. Okay, so you could like do these operations right here, and then you could implode this into a node, normalized velocity, which is pretty much what I did right here. Okay, so then you could just do this and this, and then I would have right here the normalized velocity of this guy right here. Here I'm getting the, I should be getting the character pose, not the, I'm sorry, the character pose, not the character, the whole character. So I need to do the get pose, which I did not include in my original preset. So I need to do this, and then you get here the, oh, of course, I need to tell it the bone ID, which I haven't. So I need to do the get skeleton, and then find bone again. Find bone. Then put this in here. Let's see, it's hips. And now I have the correct vector with velocity normalized by the character's speed, height. So this is some applications. You could do some prototyping, and then you could implode stuff into like this prettier nodes, and it's easier to check if your manipulation of data is actually doing the stuff you expect it to do, which it would be a lot harder to see in a MATLAB plot. Okay,